for number 3, looks like we have a fraction, and we have a variable on the top of the fraction and also at the bottom of the fraction. So here I'm going to choose to use the quotient rule. Alright, so we're going to do the denominator, as is, times the derivative of the numerator. So the derivative of the numerator would be e to some power, so that's e to the 2x power times the derivative of that power. So we're going to multiply by 2. So here's the denominator, and here's the derivative of the numerator, minus the numerator as is, times the derivative of the denominator. Alright, the derivative of 1, of course, is just 0. So we're going to look at taking the derivative of the second term here, e to the negative 2x power. So that would be e to the negative 2x power times the derivative of the power, so that would be multiplied by negative 2. Okay, all of that divided by the denominator squared. Alright, so there's the derivative without simplifying, so I'm going to simplify a little bit here. I'm going to go ahead and multiply in this monomial. So I'm going to go ahead and distribute that into the parentheses. So that would be 2 times e to the 2x power times 1, so that gives me 2 to the 2 times e to the 2x power. And then we're going to multiply both those terms, both those factors into the second term. So we have like bases. So first of all, let's bring over the 2. So let's say plus 2. And then e to the 2x power times e to the negative 2x power. So where we keep the same base and add the exponents, but 2x times negative 2x is 0, so that would be e to the 0 power. Alright, like within the second term, we don't have any pluses or minuses. We have 3 different factors multiplied together. So I'm just going to multiply all that together, so I have negative 2 times, basically think about that as like a negative 1. So it gives me a positive 2. And then once again, we multiply e and e. We add the exponents together. Negative 2x and positive 2x combine together to give 0. Okay, all of that divided by the denominator squared. I'm going to leave that as is. We can simplify a little bit more because we know that e to the 0 power is 1. So what we actually end up with is 2 times e to the 2x power. And then 2 times 1 plus 2 times 1, that's really 2 and 2. So 2 plus 2 is 4, all over that denominator squared. And I'm going to choose to stop right there and leave the first derivative just like that. Alright, so for number 4, we have a group of terms raised to a higher power. So this should sound like the chain rule. So we're going to bring the power down to the front. So I'm going to multiply the front by 3/2. So that would be 3/2 times, so we're going to write the inside function as is. Reduce the power by 1, so I'm going to subtract 1, which means I'm really subtracting 2 over 2. So we get 1/2. And then we also have to multiply by the derivative of the inside function. So the derivative of 1, of course, that would be 0. And then we look at the second term, e to the 2x power. So we know that would be e to the 2x. And then we also multiply by the derivative of the exponent. So let's simplify a little bit here. So we have a group and we have some monomials. So let's look at multiplying all the monomials together. 2 times 3/2. Well, the 2's would cancel each other out, so I'm left with just 3. And then e to the 2x power. And then we'll write the group after that. And if you want, you could go back to the fact that the raising something to the 1/2 power is the same thing as the square root of that group. So either one of these last two would be fine.